Okay, cool, right. So, my name is Oliver. I'm a software architect, so I work for a company called NodeJS API. I've been there for about 2.5 years, and I kind of specialize in our backend stack. That basically means I spent 2.5 years writing lots and lots of code. So NodeJS is a times top 100 company, and we make most of our money by selling airport parking, travel insurance, and overnight stays at hotels, and a few other products. Last year we made 4 million bookings. That's, if you consider how many people, how much traffic you need to convert 4 million people, it's quite substantial. So this is what this is a screenshot from Google Analytics from one of our websites. This was about 3 months ago. It was a Thursday, like 3 in the afternoon. It's pretty busy. If you zoom back to 4 years ago, this is kind of a very vague overview of what our stack looked like. This LAMP stack is a 40 gig VM. It's been around since 2004. If you imagine having a codebase and putting 50 developers working on it and fast forward 10 years, you can imagine what it kind of looks like. It's a monstrous legacy beast. If you kind of break it down a little bit, this is very vaguely what it looks like. So you've got this routing layer, you get sent through to this data layer, which connects out to all our internal services, systems, databases, caches, the works. It produces this kind of single object. That object goes to a presentation layer, and you get your nice template out of it, and there's your HTML, and the customer's happy. And we wanted to kind of split that straight down the middle, and just kind of pull out that data from the front end so that we could push forward. So we wanted to end up here, where we have distinct UIs communicating with one API which just deals with all the heavy lifting. And this is where we are right now, and this talk is about how we got there over the last 4 years. So the first thing we had to do was maneuver our stack into a position where we could start talking about migrating all of that legacy code. So to begin with, we took this massive LAMP stack and we added some new routes so that we can communicate directly into that data layer, bypass all of the presentation layer, and just dump out that rich object full of all the closes and data that we were going to template. So just to put that into perspective, this is kind of what an availability page would have looked like 4 years ago. And if you clicked up in the URL and you changed some of the authentication, you would have instead got this rich JSON object. So that was kind of our routing for kind of the first step. So the next thing we did is we built a proxy, put all the traffic through the proxy, everyone goes to the legacy stuff. And from there we can start talking about building some infrastructure to support a new user interface, a new API. The sole purpose of this API is just to bounce all your traffic back up to your LAMP stack, make that do all the heavy lifting, the data comes down, here's my rich data, tidy it up a little bit, and the UI is on their way. So from this point on we had 2 separate teams. The UI team batched away until they got something that was production worthy. Once everyone was production worthy, we put a little bit of traffic to it, and from that point on, we have Node in production. Yeah. So from that point on, the job of the API team from that point was to basically remove this dependency. So we were basically severing that link right down the middle. And we wanted to be here, basically. This is the end goal. So the first thing we did once we had Node in production was we looked at how we were going to actually cluster it and how we were going to auto-scale it so that when things get busy, how do we deal with that load? So we started using the Node cluster module. For reference, all of our stuff is in EC2. And when we looked at EC2, we worked out how much bandwidth we need to support all our existing queries and our caches and our responses and our requests everywhere else. And we looked at what kind of instance we need to support that kind of bandwidth. And it just so happened that we needed something that would provide with multiple cores. So going down this worker route turned out quite beneficial to us. It was really easy to start rolling deploys. So we send in a hot process signal. That causes the worker the node cluster starts 2 new workers alongside the existing 2. We then migrate all the traffic to the new workers, and we kill off the original ones. So we don't have to mess with a lot of infrastructure to get like a nice deploy pipeline going. Right. So the next important step, when you've got your stuff in production, we had to work out how to deal with third-party modules. And third-party modules are things that modules that provide external connectivity that are in NPM. So I'm talking about your Redis module, your MySQL module, your Elasticsearch stuff, your RabbitMQ stuff, that kind of thing. So the situation at the time is you've got this empty API and it's sending everything up to your LAMP stack, and that's doing all your heavy lifting over to the side. And you basically need to push all that stuff down into your API. So you need to hook all this stuff up. And we used the singletons. In the first place, we did this all wrong. Well, we didn't do it wrong, but we did it for the wrong reasons. And in the end, we worked out the right reasons for fronting all of these modules and singletons. I've got 2 reasons for you. The first reason is that about a year into our migration, we realized that we were doing a lot of repeat queries, and we didn't want to bloat our code with lots and lots of caching code. So we just hooked up our database singleton to our caching singleton and said if you pass in a parameter, you opt into caching, everything gets cached. And the second reason is for failover. So for quite a long time, we had Redis taking over nicely in production. We've got a master box, we've got a slave turning it. Everything's going well, and then one day, one of your boxes just disappears. When you're in EC2, you're kind of at Amazon's mercy to solve this problem, and that wasn't 4 or 5 minutes of downtime for us was just not acceptable. So we used our singleton to basically do DNS. Well, we looked up our own DNS records, we'd poll all our boxes, we'd work out which ones are the healthy nodes, and we'd route our caching layer to the correct node exactly at the right time. So if we go and kill a master Redis node in production right now, we have about 4 millisecond blip, and everything just jumps to the slave. It's wow. So this is where we stand right now. We've got that pass through, we've worked out how to auto scale, we've sorted out our modules, it's time to add new features. And we very quickly found that we get code in production and it would be slightly broken, or you would get like rare code paths that just don't work, or you get slightly broken logic. It wasn't ideal. And then we put features into production and everyone would be like, yeah, this is a great feature. And then about a month later, that feature would kind of mysteriously go missing. And so I'm like, where did your feature go? And like, the first time it happens, it's like, okay, that's very funny. And the second time it happens, it's like, we need to get on top of this. And when we looked at our code, we realized that our test coverage was good, but the quality of our tests was bad. That basically means that if I put up our code and I put up our tests, and I fundamentally changed our code, the tests could still pass. Now, when you're in that position, it's not a good place to be. And we realized that writing testable code is actually really hard. So what we needed was a test strategy. So we went back to our code and we looked at why is our code hard to test? And we realized that JavaScript enables you to write code in very many different ways, and very few of them are actually testable. We needed to have a test strategy. We needed like a module strategy. Like, this is how we write modules. If you write modules like this, you can test them like this. Everyone's happy. So we needed a module strategy. I've got 3 examples of 3 ideas of what form our module strategy. It's not the complete thing, but it's a bit of it. So the first idea is that whenever we write a module, it looks like this. We have a module exports at the top. You apply your stuff second. You expose all your stuff, attach this module third. Notably, these points here, we export all of our kind of like internal code, or we attach it to the module so it's exported. And we have a convention whereby if it's underscored, no one touches it, but in the tests, you can prove that each one of these works and you can stub each and every one of them. The second point is that we separate out the code that does the orchestration from the code that actually delivers like functionality. So this isn't an uncommon thing to see. I can prove that this behaves exactly how I want it to do. I can prove that this works exactly how it should do. This one should prove that it all works. The third point is every module needs to have well-defined outputs. So if a junior developer comes to me and says, oh, I'm looking at this problem, I'm looking at this code, and I've got this variable, what is it? I can point to a file and be like, it came from there, and that's what it looks like, and these are the types that you're going to get from it. It helps an awful lot in conversations, instead of saying, well, you can console log it and see what happened. Like, it's not. You need to be able to point at it definitely say, this is my data. So after we put all this live, we found that our test coverage was good, but our test quality was really good. We found that writing testable code is hard to write code that wasn't testable, and like features didn't go missing anymore. And this is a good place to be. So I'm going to add module strategy and a testing strategy checklist. So I've got all these. And the next thing we were going to do was going to start moving features. So we decided we were going to move the first feature. I'm like, right, let's go. So the first feature on our list was product ordering. So you go through an availability page and all the products kind of looks like this. All of these products are in a very specific order. Feels like quite a simple feature. So like, yeah, we'll pick that one first. There's a team in our business who put these in a very specific order. So you got them one up here, they want to push one to the end, and so on and so on. So we looked at the legacy stuff, we worked out how it worked, we looked at all the data sources that it uses to deliver it. When we started writing it, we re-implemented what we thought it did. And we wrote tests for it, and we were happy with it. We put it live, and we were like, there's no alarms going off, it seems to work. And 2 days later, one of our directors came along and they're like, Ollie, can you explain this graph for me? And we were like, you wrote that. And we realized at this point that we couldn't just keep doing this. We needed like a migration strategy. So this is the next thing on my list. So we needed a way of saying with confidence to the business that we're going to put this live tomorrow and this is going to work. And you can trust us that this will work. So we need a way of having absolute confidence in our work. So this is kind of a vague idea of what our architecture looked like at the time. You make a request in, we convert it into what the PHP stack expects, we'd send it on its way, magic stuff happens, the result comes back, we tweak it up a little bit and the UI can have it. We realised that once you've responded to the client, you can do whatever you like down here. Like, there's no reason why you have to stop there. So we took this idea of, we'd run through the legacy stack and we'd get the valid response, and then we'd take their request and we'd play it over here to the new stack. And once we've got the request from the new stack, we'd diff them, and we'd send them somewhere. In the beginning, this logging layer was bug snag, because it was just handy to hand. The main issue with this is that if you have 20 requests per second hitting the top of this kind of diff, at the beginning you're going to have a lot of errors, like especially with a legacy stack where no one really knows how it works. So you can't send 5 bug snags out every second for the next infinity. So we needed some kind of toggle switch to say do this now and don't do this later. And when we had this toggle, we had all the legacy stuff in production. We're responding to clients perfectly, and at the same time we're also running our entire new stack along the side, but at zero risk to the business. Like, people are still paying for stuff and making searches, everything's going well, but we're also testing all our new code. So to get this feature toggle going, we had to look back up on our cluster. So on our cluster we have 2 workers, each worker has to be toggled. And if you zoom out a little bit, we've got multiple boxes each with 2 workers, and we can toggle all of them. And we use Redis for this, so we already worked out how to connect to Redis early on in this talk. When every worker starts, we do a subscribe to the Redis box and we subscribe to a specific channel. And then I can come along one day and be like, I want to go and test my code today. So I'll send a request up to the load balancer, hits a worker. A worker will send a request up to Redis and it will say, publish turn on feature X. And Redis will then send that back out to every single worker. And voila, everyone's got the message, everyone turns the code on. And likewise, you can turn it off. So this is kind of our migration strategy. You pick a feature, you re-implement it, you write the test for it, put it in production behind the scenes. If it works, fantastic, put it live, absolute confidence. If it doesn't work, you tweak it, you fix it, you look at your bug, your errors, you fix it, you write more tests for it, you put it live again, and you see what happens. You just keep cycling it until it matches perfectly. And this worked fantastically well for us. So after that, then I add migration strategy to the checklist, and this is the complete list. From this point on, we moved forward and we've spent 8 months of absolutely 2 people just smashing out feature after feature after feature, putting it live. And 8 months later, we've moved all of our critical business tasks from our PHP stack over to Node. So I was going to show you what our stack looks like right now, but I don't think it would have any meaning to any of you. I can tell you that we have a culture repo on our GitHub account, and in one of these files is the rest of our module strategy. It's basically how we expect to write Node.js and the reasons behind us doing that. I'm ready for that voice to pictures. So the next slide is going to be let's look at the next 12. So yeah, I'll get it. So this is the most recent 12 months post migration. We put the migration live in July last year. So this is basically 12 months, and we've had 359 errors, uncaught exceptions in production, and there have been no lost features. It's wonderful. We've written 43,000 lines of code, 80,000 lines of tests. We've got a test coverage in the 80s. It's pretty good. But we've searched 500 million requests. Like 500 million requests for 359 hours is pretty spectacular when you've got that much code. Just to break those 500 million requests down a bit, we've made billions of MySQL queries, 26 billion cache hits, hundreds of millions of Elasticsearch queries. It's surprisingly busy. And to say that we've only had 359 errors is like a big achievement for us. We're very proud about it. Right, that's the end of my content. Ooh. I've lost it, sorry. If anyone's got any feedback, I'd love to hear it. If anyone has any questions, you're better off asking me. I'll be loitering around afterwards. If you want to join us for the kind of cool. Thank you very much.